All right, so today's video we're going to look at how to add and subtract mixed numbers. So we'll start with addition. There's a couple of techniques that we're going to use, and then we'll kind of talk about maybe which one is better in certain situations, and the same thing with subtractions. Okay, so let's start with something like 2.5 plus 5 3/5. Okay, so I want to be able to add those together. So there's a couple of methods that we can do. Okay. So first method is we can simply change them into improper fractions or simple fractions. Okay. So just as a reminder, right? If I have 2 tells me 2 pieces in a whole. Okay. If I have 2 wholes, right? So we multiply that because two wholes is going to have 4 pieces. Plus we have another one there, right? So 2 times 2 plus 1 is 5 halves. Okay. Same thing over here, right? 5 pieces make up a whole. I have 5 wholes, so that's 25. And then I've got 3 additional ones, so that is 28/5. Okay. Now again, we know that our rule for adding, or adding in this case, we have to get a common denominator. So we think 2 and 5. The least common multiple of 2 and 5 is going to be 10. So 10 becomes our common denominator. Okay. We got to multiply 2 times 5 to get 10. So 5 times 5 gets us 25. Okay, and that's times 2. Times 2 gets us 56. So now I have my common denominators, and I want to add my 25 and my 56 together to get 81/10. Okay, and let's switch that back to a mixed number. 10 goes into 81 8 times with 1 left over. Okay, so one technique when you're adding mixed numbers is to get them to improper simple fractions, and then go through your steps. Find your common denominator, change your numerators, add your numerators, get it back to a mixed number in this case, and reduce if you need to. Okay. Now, if we have bigger fractions where numbers start to get bigger, we can see where that might be an issue, right? Let's say, for example, I had to do 5 7/12 plus 11 13/15, right? And we start changing that to improper, right? We do 12 times 5 plus 7, right? So you end up with 67/12. Okay. 15 times 11, which is 165 plus 13. So then you end up with 178/15. Then you have to start thinking of what's the common denominator of 12 and 15. And then you can start to see where our numbers are going to get really big. Okay, so we're going to look at another technique where we are going to keep them as mixed numbers and then do our addition that way. Okay, so let's do that same problem. 5 7/12, 11 13/15. So I'm going to add 5 7/12. And I'm going to write this vertically, and that'll make sense here in a little bit. 11 13/15. Okay. Now the first thing to do is we got to figure out what's that common denominator going to be. Okay. So in this case, it's going to be 60. If I start listing the factors of 12, and there's there's shortcuts you can do. Like multiples of 15 are either going to end in 0 or they're going to end in 5. So you can start thinking about, well, what can I multiply 12 by? That end on 0. Well, 12 times 5 is 60, right? 15 goes into 60 4 times. So again, you could create a list, but you should know enough math at this point to where you should be able to use some of those techniques and multiplication facts and things about multiplying to help you find those a little bit quicker. Okay. So 60 is going to be our common denominator. We're not going to change it to improper. Okay. 15 times 4 gets us 60, so 13 times 4 is going to be 52. Okay, and this one we got to multiply times 5, so that's going to be 35. All right. Now, what we're going to do is we're going to add, just like when you learn to add 2-digit numbers with columns, we're going to do the same thing. So back in elementary school, when you did something like 23 times or plus 38, right, we'd add the ones column, we'd carry, and then we would add the tens column. Okay. So we're going to do a similar thing here. Okay, so we're going to start by Actually, let me get rid of this so it's out of the way. We're going to start by adding our fraction part first. Okay, so 35 and 52 make 87/60ths. Okay, and 87/60ths is equal to 1, so I'm going to carry the 1 here, and 27/60ths. Okay, so 1 and 27/60ths. So I carry the 1, right, just like we would when we add regular 2-digit numbers or 3-digit numbers. Okay, over here. So now I've got 5 plus 1 is 6. 6 and 11 make 17. So I end up with 17 and 27/60ths. Okay, and 27/60ths we can reduce. Those are both divisible by 3 to get us down to 9/20. So my final answer would be 17 and 9/20. Okay, so the advantage here is your numbers aren't getting as big as it would if you change to improper. You know, the tricky part is you've got to remember to do that, carry that number over if you get a number greater than 1. Like in this case, we got 1 and 27/60ths, so we carry the 1 over to the whole number column, keep the 27/60ths as the fraction part. Okay, and then again reduce there at the end if you need to. Now subtraction. Okay, kind of similar thing. Say I want to do 3 1/4 minus 2 2/3. Okay, so again, first technique, just like with addition, I could change it to improper. I could make that 13/4 minus 8/3. Get my common denominator of 12. Okay, that's times 3, so 39/12. That's times 4, so 32/12. And then I could do 39 minus 32 to get 7/12. Okay, so again, if the numbers are small, that's pretty efficient way to do it. Again, if we start looking at numbers like in our addition example where, you know, changing them to improper causes some really large numbers, then we might want to look at this second technique, which, just like addition, we're going to keep them as improper fractions. Okay, so let's do something like 5 and 1/5, and we want to subtract 2 and 4/7. Okay, so again, I'm going to write them vertically, just like, again, back to elementary, right? We learned to say 32 minus 18. We wrote them vertically. Okay, and we'll get back to that here in a second. All right, so we need common denominators when we subtract. So we're going to make that 7/35. 5 times 7, so 1 times 7. And then 7 times 5, 4 times 5. Right? Now, the issue is I can't take 7 minus 20. We're not going to write, and this sometimes I have students do this, we're not going to write a negative 13/35 because you can't have the front part of the number be positive and the second part of the number be negative. So we're not going to do that. Right? We're going to think back to what did we do in elementary school when we started learning 2-digit subtraction is usually when it starts. Okay, I can't go 2 minus 8, right? I'm not going to flip it and go 8 minus 2, right? Subtraction is not commutative. I have to borrow 10. I rewrite this and make it 12, and then we'd go from there. So we're going to use the same technique here. Okay, I can't take 7/35 and take away 20/35. But what I can do is borrow a whole. Okay, now here's where you got to think a little bit. Okay, if we think back to the 2-digit where we borrow, right, we usually put a 1 there. But that's because everything's out of 10, right? Base 10. Here, right, 10 doesn't make the whole. We've got 35 makes the whole. So essentially think of like a pizza. If I take a pizza that's not cut and I cut it up, in this scenario, I'm cutting it into 35 pieces. So I'm really adding 35 pieces onto that. Okay, so I've got 7 there. So this is now going to be 42, right? I've got 7 there already. I've borrowed a whole. Well, a whole in our situation, right? The bottom of the fraction tells us pieces in a whole. So since I borrowed a whole, I've added 35 pieces onto my fraction part. So the 35 I add with the 7, since there's 7 there already, to get 42. Now I can subtract 42 minus 20 is 22. Oops, let's try that again. 22, there we go. 35ths. And then my whole, 4 minus 2 is 2. Okay, can't reduce that, so that's my answer. So 2 different techniques, change them to improper. Work sometimes unless the numbers just start getting really big. Or we can keep them as a mixed number and just have to do some borrowing there to help us solve those.